Now, in the last problem, Chuck here works for commission sales, and he earns $12 for each of the first three boxes he sells. Earns $24 for boxes 4, 5, and 6, and $36 for boxes 7, 8, 9, and 10. So if he sells one box, that means that he's going to earn $12 on that box. And every time he sells another box, he's going to earn another 12 for the first three. So if he earned 12 for the first one, he's going to earn another 12 for the second, so that'll be a total of $24. And then he earns another 12, which will be 36 for selling that third box. Now, if he sells his fourth box, he's going to earn $24 on that one. So 36 plus 24 is $60. And then he'll earn another $24 for the fifth box. So 24 plus 60 is 84. And then another $24 for the sixth box. So that's 108. And $36 for the seventh box. Well, 108 plus 36 is 144. And 36 plus 144 is 180. 180 plus 36 is 216. And 36 plus 216 is 252. And what happens to the earnings, his earnings when the number of boxes he sells increases by ones? All we can say here is that earnings increase. So we can say earnings increase, but we can't say that it increases by a specific amount. Sorry, earnings increase. All right, going on. Here's our table, and it says which of these is the dependent variable, number of boxes, or earnings? Well, earnings depends on the number of boxes he sells, so earnings is the dependent variable. That means that number of boxes sold is the independent variable. And once again, earnings is the dependent variable. Now, if we're asked to graph this, well, what we have to do is we're going to put down Chuck's earnings as the title. And we're going to go from 0 up to 250, and we could go to 252. I'm going to go up to 250 just to use as much of the graph paper as possible, even though the next value is a little bit above. So what we're going up here by is by 50s, or sorry, by 25. So every other one is 50, so that's 100, 150, and 200. And we got to go from 1 up to 10, and remember there's 10 lines, so we're going to go 2, 4, 6, 8, and 10. We have to label our axes, so remember this is earnings. Because the dependent variable always goes on the vertical axis, independent variable always goes on the horizontal axis, so this is going to be number of boxes sold. And so if we plot this, and it's important that you realize that he's not going to earn anything if he sells 0 boxes. He's going to earn, for one box, he's going to earn $12. Well, that's halfway between, just a little bit less than halfway between 0 and 25. And if he sells 2 boxes, he's just going to earn $24, which is just below 25. And when he sells 3 boxes, he's going to earn $36. Well, halfway between 50 and 25 is 37.5, so it's just going to be just below half the way up. And we're not going to draw a line here because what you have to, one important thing here is these are discrete values. Chuck can either sell one box or two boxes. He can't sell 1.5 boxes. So we're not going to join a line because there's only these possibilities. He can sell one box, two boxes, or three boxes. So we're not going to join the points with a line. And if he sells four boxes, he's going to earn $60. And 60 would just be below halfway because halfway between 50 and 75 is 62.50. For 5 boxes, it's $84. So that's 75. So somewhere in that neighborhood. And 6 boxes will be 108, which will be a little bit below halfway between 100 and 125. 7 boxes is 144. 8 boxes is 180, which is a little bit above 175. 9 boxes is 216. And 10 boxes is a little bit over off our graph here. So what we have is 3 different regions. So here is the first region, the first 3 values, where the slope of this is not very steep. Then there's an increase when he earns $24 per box, and then there's a greater increase when he earns $36 per box. So the shape of the graph here then is nonlinear. Nonlinear relationship here because it's a lower slope here, then a higher rate, and then an even higher rate at the end. And the first differences are different again. And once again, whenever first differences change, we have a nonlinear relationship.